Hey guys, welcome to the channel. So if you have seen any of my previous videos, especially the Docker related ones, you might think to yourself, what the hell? Why is this guy talking about Docker? I mean, this is an electronics channel or more like a smart home channel, so why Docker? We are not software developers, or maybe we are software developers, but we came here for turning lights on automatically and stuff like that. So what is all this thing about Docker? Well, in this video I will explain why I'm so obsessed with Docker and why you should be too if you are building a self-made smart home or you are just running various software on a home network. So stay with me. First of all, for all those people who somehow missed this whole hype around Docker, what is Docker? Docker is basically a piece of software that makes you able to run other software in separate, isolated environments, which we call containers. In this video, I won't go into too much technical details about Docker itself, how it works and stuff like that, because I meant this video for people who are debating whether they really need Docker or they haven't heard about it yet, but they want to learn why it can be useful for their smart home. Okay, so let's start with an example. So you have a smart home and you run, for example, Home Assistant as your smart home hub. Then you buy a 3D printer and maybe you want to run Octoprint, and you also have a file server, and you want to watch your own videos on your TV or on your smartphone or tablet or whatever. So you will end up installing something like Plex and so on. And eventually you will realize that your house is cluttered with Raspberry Pis, different software installed on them, maybe some on your PC or on your NAS and so on. And at this point you realize that you have to handle all that mess, and you keep the softwares up to date, security patches, whatnot. So because of this, eventually you will start saying that I don't need this, I don't need that, and stuff like that, and then you will miss on some great features. Or you can say, okay, I'm not updating this, I'm not updating that, and not configuring this and not configuring that. And in that case, you are just attracting hackers and botnets and whatever, because yeah, security leaks are found each day, and basically, even for the sake of security, you have to keep your operating systems, your servers, your whatnot up to date, and also not counting the new features, patches, improvements and whatnot. So either way, you will end up doing maintenance for these hardware or software components, and it will consume a lot of time for you. Also, if something goes bad, for example, for a Raspberry Pi, which is running software off of an SD card, you will end up using your settings, so you will have to reinstall again, assuming that you don't run around in your house pulling SD cards from Raspberry Pis, backing them up on your laptop or something like that, then putting them back in. Either way, you end up with a lot of maintenance. And this is actually where Docker comes into the picture. It can help you a lot. And you might say, okay, but Docker is a developer tool and it requires some Unix voodoo and whatnot. No, it's not. Actually, it's much easier than you think. Actually, learning Docker and using it with your home network and the software you are running on your home network, especially if you're running a smart home, it's much easier than maintain all those different pieces together. Now let me show you an example. What you see here is a very simplified version of my home network. So I have a wired LAN plus a mesh Wi-Fi consisting of multiple routers and a lot of devices. So let's start here. We have two separate instances of Kodi. Kodi is a media player and this is running on a Raspberry Pi. So I have one for the kids, one in the living room. And then we have Octopi. Octopi is for my 3D printer. Then we have Pi-hole. Pi-hole is also running on a Raspberry Pi. It's for filtering adverts for all the devices on the network which are using internet. and used for browsing internet. Then I have Home Assistant because it's a smart home and I need some kind of software to manage all the smart home related things, which is called basically a smart home hub. Then because we have a lot of media files, videos about the children and whatnot, we have a media server. Then this is what I call a home automation database. It actually more than a database, it uses ELK stack. ELK stands for Elasticsearch, Logstash and Kibana, and these tools together are used for collecting and analyzing and filtering sensor data. Then we have our smartphones, and of course when guests coming and joining the Wi-Fi, they also have their smartphones. And because of the smart home, we have a lot of sensors and smart light bulbs and smart sockets and Sonoff devices and whatnot. Finally, there's game console because game console can also act as a media player, and this is also connecting to the media server. And of course, we have two PCs, one for my wife and one for myself. And as you can see, it's pretty much a nightmare to maintain. So if you were in my place, or actually this can be in your situation, that you wish that at least half of these devices could be just disappearing without actually losing their benefits. So what can we do here? How can Docker help? So what are these red markings? Are marked the devices that are now not standalone devices anymore. Now in fact these devices are running on the same physical hardware, a simple lightweight server. And it's easier to maintain, but also other than that, Docker brings a lot of other benefits. So let me show you those. So the main question is, in what ways Docker can help you at home? Well, as I already mentioned, Docker helps you reducing hardware costs. Believe it or not, having a simple lightweight server which hosts all the stuff I mentioned in the previous slide doesn't cost more than a couple of Raspberry Pis. So you can pretty much use any desktop PC grade hardware nowadays for this, and it will be a pretty stable server, unless you are of course planning to use that server for serving a high traffic website or something like that, because for that it won't be suitable. But for example, you can use an Intel Celeron or an AMD Ryzen, even the cheaper ones, whatever. Then reduces network load, because especially those components are communicating with each other, then normally they are doing through the network, but now they are sitting on the same host, so there goes network communication. It will be just happening on the same host without going to the router and stuff like that. Then we can safely state that Docker greatly reduces provisioning efforts. What is provisioning? Provisioning is pretty much a fancy DevOps word for installing stuff and configuring stuff for a server or for a PC or something like that. So one of Docker's greatest strengths is helping you with provisioning efforts. When you are installing software in a normal way, it usually happens by installing the software, then configuring it. While using Docker, you can prepare the whole configuration thing and just have it installed together with the software. Whoa. Let's stop for a second. Did I just say configuration, as in Linux configuration? Yeah, I just did. And actually, if you have seen Linux, then you know that in most cases configuration means a lot of files scattered around the file system, this file in this directory, another file in another directory. Now this is not necessarily true, but there are pieces of software when it is true. And even if you are working on a single machine, then backing up those configuration pieces and various files can be tedious. And actually Docker helps you with that, with a feature we call volumes. Now this video is still theoretical, and I'm trying to actually sell you the idea of Docker, not going into technical details. But let's just say that having your files scattered around the file system won't be a problem anymore with Docker. So once configured properly, you can be sure that all your files you need to take care of, like backing them up and protecting them somehow, will be handled and protected by Docker. And even if you have to set up backup processes manually or using some automated tool, it will be still much easier. Now let's get back to that list. So the next point of our list is that Docker reduces software maintenance time. And by software maintenance, I mean handling those configuration files and data. And as I've partially explained already, it helps you with the help of volumes and whatnot. And the next item is that Docker makes it easier for you to backup settings and data. And this is also true, because partially because of the volumes I mentioned before. And also because you have everything in one place. You don't have to run around in your house to pull out SD cards for backing them up and stuff like that. You can just set up a RAID or a mirror or something like that to have an additional layer of securing your data. And you can also set up automated backups. Optimizes hardware resource usage. This can be a tricky concept for someone who is not really into technical stuff like operating systems and whatnot, but let's just say that having separate Raspberry Pis means that there are times when the Raspberry Pi just sits idle. For example, if you use a separate Raspberry Pi for your 3D printer, when you are not printing, then that device just sits idle. Now, having more devices sitting idle, consuming power, doing nothing, not the best solution, to say so. Instead, having larger capacity, like a server, even if it's not really server-grade hardware, but let's say a low-power PC or something like that, still, the operating system can solve this problem for you, because all those pieces of software will be optimized by the operating system and by Docker, of course. If something does not consume resource at the moment, then that resource will be allocated for something else. So your applications are dynamically sharing the resources of the hardware, instead of just sitting idle with a dedicated amount of resource, like in the case of having separate Raspberry Pis. Okay, next point, enforces need-based access to resources. What the hell does that mean? Actually, it means that when you are setting up something and you put it on your network, all the devices, let's say it's something like a small server, or let's say again, Octoprint. It sits on your network, it opens up a port for communication and everything can access it. While on the other hand, with Docker, you can create rules like this port can be accessible from the outside, this port can be accessible from a given container but not from the others, and so on. So it's like having separate subnets within your network, and you can define rules, you can hide ports, you can open up ports for the whole network or for other containers. So that's what I mentioned. It's actually needs-based. You can set up everything according to the needs of your applications. Now, to be honest, Docker's networking is such a sophisticated solution that I could dedicate a 1-hour video just to describe it. But out of the box, it works very, very nicely. And you don't have to go deep into how to set up networking in Docker unless you really want to, or you have some really specific needs. And for the last point, which is pretty much my personal favorite, let me tell you a short story. So a couple of years ago, I had a small home server and I wasn't using Docker back at the time. And I installed a couple of different software on that server, and one of them had a bug. And because of that bug, a user was created with a default password, which is easily guessable default password. And that user was allowed to be used as remote login to that machine. Now guess what happened? Some Russian, or I can't remember, bot found that. Actually, because it was scanning for computers over the internet, and this server was opened for the internet, and this bot found that user with the default password. So the next morning I came into the study. I found that that server is really busy. I was like, what happened? And guess what? The bot just penetrated the server and installed a replica of itself, and now my server was trying to attack other machines over the internet. And I was like, oh my god, shut it down. And yeah, I shut it down, but with it I've shut down all the prepared configured pieces of software I was running on the server. So I was devastated that I had to start the whole provisioning process again, install a new operating system, do everything from scratch, install all the pieces of software, do all the configuration, and of course go to Stack Overflow or whatnot to check out what this bug was, because I had no clue, and it took like, I don't know, days to investigate and fix this problem. And yeah, this is the point where Docker could have helped me, because by default Docker doesn't open up ports just like that. You have to specify that I want this container to be accessible from the outside, and this wouldn't have happened with Docker. But for the Phoenix server and for infrastructure as code, what does this mean? It's about rebuilding the server. So the Phoenix server is a concept I really like. It means that whenever something disastrous happens to your server, like it happened with mine, you can just rebuild it like the Phoenix is reborn. So the question is, when your home server gets penetrated or it burns down, physically, or the PSU blows up or something like that, how long does it take for you to reinstall everything, to reconfigure everything, to have everything back up and running exactly the way it was? And this is where infrastructure as a code and the idea of Phoenix server helps you with. And Docker excels at this. Using it together with tools like Docker Compose, you can have everything scripted, everything prepared, and when disaster happens and you need to rebuild everything, you can just issue a single command and everything will be up and running in, let's say, half an hour or something like that. Because of all the descriptor files you create. And this is awesome, trust me. When you are a home user and you don't have fancy server grade upgrade, you have to be prepared for disaster. And when you are a smart home owner and you are running your own smart home hub, let's say Home Assistant, you have to be prepared for disaster, because you cannot say, for example, to your family that the lights won't work for 2 days because Dad is reinstalling everything and stuff like that. It's just stupid, right? Okay, with this last point, we have just went through all the major features, or much like key points Docker brings you. Now, in the future, I will probably create more technical videos on Docker, but from the smart home perspective, from home networking perspective, I don't want to assume that you are a developer and you want to develop your own Docker-based application and stuff like that. I want to create videos for you, for the average user who just wants to have a nice DIY smart home with a working, stable and secure network and a stack of software components needed. Because if you are a tinkerer like me, you will eventually end up with database containing sensor data and stuff like that. Believe me, when I started, it was just a router and the PC and the smartphone. And now look at what I have. Anyway, let's wrap this video up. I hope you enjoyed it. It wasn't as technical as my usual videos are, but I hope that it brought to you usable information, useful information, and maybe ideas, or just some interesting story. Who knows? Anyway, if you like this video, please hit the thumbs up button, and if you're not subscribed to the channel yet, please subscribe. It will help me a lot. And if you have questions or some story to share, or whatever you want to tell me about the video, like what I should do differently and stuff like that, please use the comments. Thank you for watching this video, and see you next time. Hey, thanks for watching this video. If you liked it, hit like. If you want to help my channel and see more of my content, hit subscribe. If you want to check out behind the scenes and want to know more about me, then follow me on social media. You can find the links here. Thank you again, and see you next time.